Hello everyone, this is Tuesday's lesson and we're going to look at scale factor for area and volume. Okay, so there's two videos to watch, one for area and one for volume. Again, if you feel confident with this, you might want to kind of skip bits or something like that, or if you feel really supremely confident, you might want to go straight to the exercise and have a go at them. I'll leave it entirely up to you, but I'm going to go through some examples and it might be worth watching just to kind of remind yourselves how to do it. Okay, so let's get into it. So these are the two exercises I want you to do. Okay, so let's look at what happens to the area of a shape if you scale it up. Okay, so let's look at like this example here. I've got these two rectangles which are similar. So this side's 2 centimeters, this side's 4 centimeters. And what I'm going to do is I'm going to multiply all the lengths by 3. So actually, let me write that here. So all the lengths are going to be scale factored by, going to be multiplied by 3. So this is the scale factor for the lengths, it's 3. So if I multiply all the sides by 3, so 2 times 3 is 6 centimeters, and 4 times 3 is 12 centimeters. So lengths are multiplied by 3. What happens to the area of both rectangles? Well, okay, so the area of this rectangle is 8 centimeters squared. Centimeters squared. And the area of this rectangle is 72 centimeters squared. But what's happened to these two numbers here? What's happened to them? Well, if you look at it, 8 multiplied by 9 is 72. So the area has been multiplied by 9. The lengths have been multiplied by 3. So how are these connected? Well, I hope you kind of find this obvious, but 9 is 3 squared. So the area of these two similar shapes have been multiplied by 3 squared. So that's how kind of like scale factors are connected. And let me just summarize that real quick for areas, sorry. So if the scale factor for lengths is something like you multiply them by 3, actually let me do it better. So I've just drawn a little table here to summarize this. So if the lengths were multiplied by 3, so if the scale factor for any length was multiplied by 3, then the area would be multiplied by 3 squared. If it's, 3 squared, which is 9. If the lengths were, for example, doubled, then the area would be multiplied by 2 squared, which is 4. So if the lengths were multiplied by something like 1.6, then the area is multiplied by 1.6 squared to get from the small one to the big one. So I hope that kind of makes sense. And if you think about it logically, remember like areas is written as centimeters squared, meters squared, and so on. It's kind of like the same principle with the scale factor. So here, for example, if I multiply, so the area of this one is 8 centimeters squared, but if I multiply the lengths by 1.6, I'm not even going to bother working that out. So this would be 2 times 1.6, and this would be 4 times 1.6. The area, though, would be 8 times 1.6 squared. So let's just work that out. 8 times 1.6 squared. 8 times 1.6 squared is 20.48. So that's what the area, centimeters squared, would be for this rectangle here. And I hope that kind of makes sense. So let's look at some example problems with this. Okay. What you could do is okay, so let me tell you the question first of all. I want you to work out the length of this bottom edge here. And you give them the area of both triangles. So what you could do is you could pause the video now and see if you can do it yourself. So pause the video now and do it. Okay, this is the work through of how to do it. So first of all, we know the area of both triangles. So if I do scale factor for area, and I'm just going to do the same principle, big divided by small. I'm going to do 900 divided by 25, which I think is 36. Yeah, it's 36. So the area was multiplied by 36. So if I go to that little table, So this is the length, this is the area. The area is multiplied by 36. So the length must be multiplied by the square root of 36, so that would be 6. Well, if you think about it, remember that principle. If the length was multiplied by 3, then 3 squared would be this for the area. So we're kind of working backwards here. So that means all the lengths were multiplied by 6. So if that's 7, the corresponding side would be 7 times 6. That's 42 centimeters. That's how long this side must be here. And I hope you got 42 as well. So I hope you kind of got your head around that. So the area was multiplied by 36. And so the length must have been multiplied by 6. Because remember, 36 is 6 squared. So that's what the length must have been multiplied by. So 7 times 6 is 42. So that's kind of like how long that side is there. Okay, so let's just do one more problem. Now, here's the thing about area. When I say like scale factor for area, it could also mean surface area. Any type of area, really. So it's also surface area of 3D shapes. So that's one of the things you can consider as well. Surface area of 3D shapes could be scaled up and scaled down in the same principle. So here, for example, we have two cylinders which are similar. So I'm telling you that they are similar. Okay. This one's got a height of 15. This one's got a height of 36. This one's got a surface area, so I'm going to put S.A for surface area of 622 centimeters squared. They are similar, so I want to know what the surface area of this larger cylinder is. Now, when I say surface area, I just mean the area of each panel that makes this cylinder. So remember, it's two circles plus a rectangle, which the rectangle is kind of like the curved bit, and that's kind of like the area of that cylinder. But I want to know what the area of this larger cylinder is. And the thing is, though, we don't know the radius or anything like that, but it doesn't really matter because we can still work out what the surface area of this larger one is by using the surface area of the smaller one, because surface area, it's just the same thing. Okay, so first of all, I'm going to work out the scale factor for lengths. Now, the two lengths are 36 divided by 15. Okay, so 36 divided by 15 is 2.4. So that means all the lengths were multiplied by 2.4. And when I say length, I literally mean any length measurement. So it could be the radius or the circumference or the diameter. Any kind of measurement in terms of length was multiplied by 2.4. Okay, so that means the area, to work out the area of the larger one, we just need to take the area of the smaller one, the surface area of the smaller one, and multiply by 2.4 squared. Okay, so remember that little table, length, area. If the length was multiplied by 2.4, the area must have been multiplied by 2.4 squared. Okay, so let's work that out. So 622 times 2.4 squared is a large number, which it would be. It's 3,582.72 centimeters squared. So that is the area of that larger surface area. Sorry, I keep forgetting to say that. Surface area of that larger cylinder. And that's because these two are similar, because I told you that they are similar. So that's what it's got to be. Okay, so you didn't really need to know the radius of it. Okay, so the next video talks about volume, which is a very similar principle, and then it summarizes the whole thing. And then that's it for Tuesday's lesson. It's probably a good idea to watch some questions. Sorry, do some questions now from Caboodle. Okay, thank you for watching this, but please watch the second video as well. Thank you, guys.